Outliers, what are they? How do we find them? And then what do we do with them? These are all great questions, and I'll talk about all of them in the next 6 minutes. Let's go!
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Hello again. Mark here. Welcome back to 6 Minute Statistics, where I explain one topic at a time in simple and straightforward language that is surprisingly easy to understand. Before I begin, please take a moment to like this video and subscribe to my channel. That way you'll get updated when a new video comes out so you don't miss out on any of the topics that I'm talking about. Now let's take a look at outliers. We begin with the definition. Wikipedia defines outliers this way. In statistics, an outlier is a data point that differs significantly from other observations. Others define it similarly. Sounds simple enough, but there's no consensus on what differs significantly means. So I'm going to give you my take on the topic. Outliers are the values that fall out there, somewhere in the tail of the distribution, somewhat displaced from the rest of the data. Still pretty murky, right? Well, maybe looking at the two most common methods of detecting outliers will help. Z-scores and box plots. Let's begin with Z-scores. Earlier, we looked at some rules to help us understand how a standard deviation works and how to interpret it. We ended up saying that most of the data in our data set will fall either between 2 or 3 standard deviations of the mean. Another way of saying that is between the z-scores plus and minus 2 or plus and minus 3. The rule that we use depends on what the shape of the distribution is. If we're working with empirical rule data, or mound-shaped symmetric, and even skewed data, we would do plus and minus 2. If we were working with other types of data and had to invoke Chebyshev's theorem, we'd bump that out to plus or minus 3. So if we expect data to fall within plus or minus 2 or plus or minus 3, I'm going to define the outliers to be the values that fall outside those values. Now, with the way I'm defining it, I do know that upwards between 5 and 10% of my observations I'm going to label as outliers. So I'm not going to get too crazy with outliers when I find them. I should also note that a z-score of 4 would indicate the observation falls much further away than an observation that has a z-score of 2.1. That's going to impact what we do with the outliers as well. Before we go there, let's talk about our second method of detecting outliers, box plots. Box plots are graphs that identify outliers using symbols in the plot. Depending on the software used, the symbols can vary. In addition, the terminology that we use with outliers can vary greatly from one person to the next. Sometimes people will use terms like outliers or suspect outliers or even highly suspect outliers to identify whether an observation falls far away or not. When I work with z-scores, I typically use the terminology outliers or they're not outliers. When I work with box plots, I use suspect outliers, and instead of using highly suspect, I just use the phrase outliers. Be ready to adapt the terminology that is used in your field or the teacher in your class. Here are some examples of box plots using the same data set in 3 different software packages. I asked students to estimate how many hours they exercise per week. The different software all identified values that were extreme, but they each provide a slightly different take on the matter. One of the software packages uses the same symbol to identify both types of outliers, while the other 2 packages use O's and asterisks, but they use them differently. In one case, the asterisks represent the suspect outliers. In the other, the asterisks are the outliers. So go figure. The bottom line is you need to get comfortable with the software you're going to be using and the terminology that either your teacher or your field of study demands. Now, once we identify outliers, what do we do with them? Some suggest getting rid of all outliers as they mess up the data and the resulting analysis that we perform. They argue that the analysis will get better and we're going to read that as more accurate once the outliers have been eliminated. I'm going to have 2 problems with the approach. First, after deleting outliers from your data set, when you rerun the analysis, there's a very good chance you're going to identify other observations as being considered outliers now. What do you do with them? Get rid of them? And then rerun it and go over and over and over again? That seems dangerous to me. The second reason I don't like just getting rid of outliers is I think that's an opportunity to learn something. There's variation in your data, and the outliers may give you an indication of what's causing it. By studying the outliers a little closely, you may be able to come up with the reasons why there's so much variation in the data. Now, I'm not opposed to deleting an outlier if I can come up with a good reason why it shouldn't be in the data set. If there's something concrete that would make me suspect that observation is never going to happen again, then I'm okay with getting rid of it. But just getting rid of it because it doesn't conform to the other values in the data set, I won't do that. Now, let me end with a caution. If you get in the habit of deleting your outliers from the data set, there's a very real chance that the variation in your data is going to be underestimated. You're going to feel that you have more accurate information than you really have. And so it wouldn't surprise me if the analysis you're conducting don't play out when you look at real data. You expect observations maybe to fall between here and here, but you continually observe observations that fall further away. It's a really good chance that deleting the outliers caused you to have a very optimistic view of your data. And that's going to close out this conversation about outliers. Hopefully these 6 minutes have helped you to understand them better, helped you to come up with 2 different ways to identify them, and also talk to you a little bit about what you should do with them. Now it's your turn. Go ahead and look at some data and try to identify the outliers in your data set. So, what do I always end with? It's time to get to work.